one final note on the lower end of the range. So the upper end, we establish, where does it stop being linear, and then we say it's not okay once we get to that nonlinear part of the curve. But the lower end of the range, right down here, there's also a limit to how low in concentration you can go. Eventually, your technique isn't sensitive enough to measure the difference between 10 parts per billion and 20 parts per billion. You just don't get enough signal to be able to differentiate those, just as an example. And so we need to define that as well, that lower end. So there are actually two different types of limits. We have the limit of detection, and this is generally defined as, the accepted definition of this is a signal that is 3 times greater than the signal from a blank, than the standard deviation of the signal from a blank. Basically, if there's nothing present, you're going to get a certain amount of signal out of that will be a little bit bigger than 0 usually. And if you take the standard deviation, you do that measurement of your blank several times, that gives you sort of the range of difference, differences in that value you'd expect. And if your signal is 3 times larger than that standard deviation, we say, okay, there's something there. That's our limit of detection. Basically, we're saying is 3 standard deviations above what you'd expect for just nothing to be present. Now, mathematically, how do we define this? So we take that S, this will be that standard deviation of a bunch of blank samples. And so let's, mathematically, we can state that this would be 3 times S, and then we divide by the slope of our calibration curve. Now, if your signal is at this sort of level, it is not, this is sort of the limit at which we say, is it present? But it's hard, at this sort of level, it's hard to say how much exactly there is. So you can't quantify it very well. So there's a different range that we call the limit of quantitation. And this is where you can actually quantify the results. And it's similar to the limit of detection, but it's instead 3 times larger. So the limit of quantitation is that is 10 times larger instead of 3 times larger. That is 10 times larger than what we've defined as S here, right? Than the standard deviation of the signal from blanks. So that means that mathematically speaking, we take 10 times S divided by the slope, and that'll give us the limit of quantitation. This is the smallest amount that can be measured with any sort of reasonable accuracy. Once we get down to below that 10 times the standard deviation, we can say that it's there, but the sort of range of values you'll get from that peak or from the signal that you get makes it difficult to actually get an accurate quantitative result. So when you're below the signal limit of quantitation, you can generally say, give qualitative answers like, oh, there is the thing that I'm looking for is there, but you can't really say exactly how much of it there is until you're at that 10 times level at that limit of quantitation.